This screencast is going to look at the Eurovudas question, focused particularly then on product costing and interpreting the numbers. So again, ideally you'll have looked through the slides in terms of the material covered, and particularly you'll have attempted the OLATA question before you go on to Eurovudas. So try yourself, pause this screencast, go back and see can you attempt some of the requirements first and read through the question, and then when you get stuck, come to the screencast and we can work through each particular area. So I'm assuming you've read through the question. In this case, you're asked to do 4 requirements. First 2 are to calculate the cost per unit for both cabins. So you have 2 cabins in this company using the traditional method where direct labour costs. So in OLATA we had direct labour hours, but direct labour cost now is the main driver. And then we're asked to use activity-based costing for part B. And similar to OLATA then, we have to discuss and comment on the differences. So why is the Brighton cabin different in part B than it is in part A? So that's really about interpretation. And finally then, D is suggested any additional factors which may have contributed to the decline in the company's profitability since this new cabin was introduced. So particularly here, part C, part D, you'll see a lot of them as you move towards more exam standard questions about interpretation. So that's a key thing we're looking for in terms of the learning outcomes for the AC548, is that you can actually interpret the numbers. It's one thing being able to prepare them. A lot of the time you'll be given numbers and you need to be able to interpret and explain what they mean. So the background context to Eurovudas is it's not dissimilar to the OLATA question before. You have 2 products. You have the Brighton cabin and you have the other cabin which is called Essex. So Essex is the more established one, the standard log cabin. And then there's this new cabin they've introduced for the European market, and it predicted increased sales and profits following the introduction. However, the problem is 6 months, sales have been better than expected, but profits haven't been. So they wanted to understand what's going on. So why is it the profits have not been as good as expected, yet sales have exceeded expectations? And we're given information then about the direct cost per unit. So they're the ones we can trace directly to each of the cabins, the volume, and then we're given the overheads. So it's 4.5 million of manufacturing overheads, and they've given you 4 different cost pools. So a lot of the time the cost pool is somewhere between 3 and 5 in most questions that we look at. And you're given a number of drivers then in terms of level of activity. So this is a good practice of the principles we've already looked at OLATA, and we're gradually building our knowledge base onto more exam standard questions and more detailed interpretation. So the first thing we're going to look at is the traditional method, and we're going to get the cost for Essex and the cost for Brighton. So again, pause the screencast yourself and make an attempt. Well, for the traditional method, you're going to have direct cost and you're going to have indirect cost. And the direct cost is relatively straightforward. You have the materials and you have the labour. So note in this question we're not actually asked to do out the cost base and interpret how much is indirect and how much is direct. So that was asked in OLATA, but in this one we went straight into the calculation of the cost per unit. So different questions will have different requirements. So here the cost of materials per cabin is 112.5 and 25, taking those direct from the question, and 187.5 and 50. So you can see we can trace those directly to the question or directly to the products because they're direct materials and direct labour. However, the problem is then when we get to indirect, we don't know how much of the 4.5 million should go towards Essex or should go towards Brighton. And what we do there is we're going to have some basis to allocate. And the basis we have here in the traditional method is as a proportion of direct labour. So just bear in mind, watch the difference here. It's direct labour costs. So it's not going to be in proportion to direct labour hours here, it's direct labour cost. So we need to get the total overhead and the total of the driver, which is direct labour cost. So we'll call it DLC. So the total overhead, so remember, go back to the slides in terms of steps. I'll just bring it up here. You estimate the total overhead for the traditional method is 4.5 million. We have the relevant driver, in our case, is direct labour costs. And then we put one over the other to get a rate per driver. So a rate per euro of direct labour. So in OLATA we had a rate per hour of direct labour. Now we're going in cost terms per euro of direct labour. So the total overhead is 4.5 million. So let's change that to millions. Direct labour here for Essex, we have to calculate. We have 32,000 units at €25 a unit. So remember, we're looking at the total here, not on a per unit basis first, because we're looking at the total overheads. So you work on total first and you work back to per unit then. So total labour for Essex is, let's tidy these up, 800,000, 32,000 at €25 each, and then you'll have 4,000 at €50 for Brighton. So we can see here the total direct labour in the company is 1 million, of which 80% is Essex and 20%, 200,000, is Brighton. So that's the relationship we're going to use for the traditional method to say, well look, if Essex use 80% of direct labour cost, it should get 80% of the overhead, on the basis that that's a direct relationship. The more labour cost you have, the more overheads. And we know from prior questions and prior discussions in class, that may be too crude. But 80%, 0.8, so we'll say 80% there, and 20% for Brighton. So they get a fifth. So we've allocated the 4.5 million, 3.6 million to Essex, and 900 grand to Brighton. So we're saying 80 is to 20, because the main driver we're using is labour cost. So that's the way you can look at it. You can do it in that proportion. The alternative way, and some students want to do it this way, that's fine. You can put one over the other. You'll say 4.5 million of overheads over 1 million of costs will give you, just take that out to one decimal, €4.50. And how you interpret that is €4.50 overhead per €1 of direct labour. So that's how you interpret that. So either one is acceptable. So what that means, let's just make it a small bit bigger, is for every euro the product uses of direct labour, you give it 450 of overhead allocation to cover all your extra costs. So it is typically an approximation done at the start of the year, but you try and keep it as accurate as possible. And the logic being here is the more direct labour you use, the more you consume overheads. That's the assumption we're making using this method. It may be good, it may be bad, but that's the assumption. So in this case, if we use these interpretations to get a per unit, there's two ways of going about it. You can either say it's €25 times 450, because remember every euro of direct labour gets €4.50 of overheads. So same here, it's 50 times 450, and that will get you to your 112.5 and your 225. If students went the other way, which is fine as well, what you will do is you'll take the total overhead allocated to Essex, which is 3.6 million, and divide by the number of units, which is 112.5. And for Brighton, you give a total overheads of 900,000 divided by 4,000. So both are going to come to the same answer. I don't mind which method you use, as long as you're comfortable with where you're getting the answer, and more importantly, that you come back to the same answer as in the solution. So we'll just take out those for now. That will give us the total cost per unit to be materials plus labour plus indirect. And the same for Brighton. So 250 and 462.5. Now, one key insight if you're looking for students to make comments here is, one good thing we want students to pick up on is, essentially the indirect costs are nearly half of the total cost. So that's a very important point, because if we get this allocation wrong, it will have a massive swing in the pricing of both products and the profitability of both products. So when I'm looking for students to make comments in subsequent requirements, we're seeing can students pick up on the importance of these aspects. If you're looking at the numbers, it's not just learning off how to do them, it's actually interpreting what they mean and the implications of the numbers that you're given. Right, so that's the first part, part A. You're asked the question, calculate the cost per unit if overheads are allocated in proportion to direct labour costs. So we assume one cost driver. But now if we're asked to do the cost in activity-based costing, we're now going to have 4 separate drivers because we've looked at 4 separate activities with 4 separate cost pools. So we're still allocating the 4.5 million. That won't change. But what we're doing now is we're looking and focusing on the activities. So as per the slides and the notes, we're focusing on what activities are the products consuming. So what does Essex consume in terms of retooling, in terms of indirect labour, in terms of deliveries, etc. And what activities does the Brighton cabin consume as well? And do they consume them in an 80-20 relationship? Because remember, that's the relationship we've done already. We've assumed it's 80-20. We've assumed that Essex consumes 80% of all the activities, the drive overheads, and Brighton consumes 20. But that may not be the case. So now we're going to do ABC cost per unit. And setting up the question again, you have Essex and you have Brighton. Now remember, at the outset, the direct labour, direct cost does not change. So I'm just going to take down those from before. So you might set it up as well in your question. Just delete those. The direct costs do not change. So this activity-based costing is only interested in the overhead. So we can trace 112.5 and 25 to Essex, and the same for Brighton. So they will never change, they're accurate. But what is going to change is how we allocate the rest. And we're going to look at the overheads in machine running, store requisitions, material moves, and setups. Right? And you're given the activity measures. Now sometimes in a question you may not be told what the driver is. And I may give you drivers and you trying to come up with what do I think is the best driver to explain that cost. So if I took out this column here, you may still be able to figure out what the relevant ones are. So I may ask you to articulate which one you think is most appropriate. So just bear that in mind. You may not be told which the driver is, but you'll be given enough information for you to justify which one you would use. So for example, for machine running costs, the best proxy is machine running hours. So the more hours you do, the more cost in that cost pool. Likewise for store requisitions in the storehouse, you'll have the number of requisitions will obviously drive the more costs. Same with material movements and number of setups. So relatively intuitive based on this question. So in this case, similar setup to before, you have the total cost 910,000. You have 1895. You have 675 and 1020. So I'll just tidy up those to make them thousands. So they're still the 4.5 million we're allocating. We've just split over 4 different cost pools now. And what we're interested in is what's the driver and what's the cost per driver. Now you can do this a shorter way, and that's fine. But the key thing to note is you may need to do it out like this for other purposes we're going to cover next week around activity-based management. So if you get the same answer, that's fine. Just bear in mind you may need to do these calculations as well for other requirements in the question. So the driver here is machine hours, of which we have 17,500. Right. So that means the cost per machine hour, based on our estimate, you put the cost over the number of hours, is €52 per machine hour. So that's our best estimate of what that cost will be. €52 per machine hour. Here we are looking at the number of store requisitions. So it'll be 1.8 million over 1,000, which is 1895 per requisition, REQ. Right, so we're just interpreting what does that mean. That's per requisition. For here you have 450 material movements. So 675,000 over 450 is per material movement. Now this is not an exact science, but it's good interpretation to give us an idea of the cost of activities in an organization. They were saying, why do we have so many movements if it's costing us approximately 1,500 per movement? And finally then, number of setups is 75, and it's costing us $1 million for those. So approximately 13.5 grand per setup. So quite expensive in terms of setting up. And we can then use those to allocate to each of Essex and Brighton because we know how many each drivers they have. So you start off on the total and get a cost per driver, which is useful in its own regard in terms of managing activities. But then we take for Essex and Brighton. So I'll just open up this in a second, bring it over a bit. For machine running, they have 7,500 machine hours times €52 per machine hour. So they're going to get 390 grand. So we're just allocating out that 910,000. Likewise here, it's 10,000 machine hours for Brighton times 52. So the key thing is the total allocated across both of them will be your 910. And if you want to do it like this, it's fine. The quicker among us, the quicker students will probably say, well, it's just 910 times 7.5 over 17.5. So you'll get the proportion of each and use that ratio. And that is fine. If you do it quicker like that, as long as I can see your calculations, you'll get full marks. But sometimes you'll need this to be able to answer the activity-based management parts of the question for insight. So just watch out for that you may skip too many steps and lose some vital information. Same for requisitions. It's actually half and half, so it should be easy to divvy up. We'll do it the longer way. It's 500 times 1895 per requisition, and it's 500 times 1895 per requisition. So it's just split half and half. Here it's 325 movements times 1500 and 125 times 1500. So we're still splitting the 675 just across 2. And finally then for the setups, 50 setups here times 13,600 and 25 setups times 13,600. So your starting point for activity-based costing is always get the totals and divvy them up between the number of products. This is only 2 products. In other questions you may have 3 products. So that means we're giving overheads to Essex of 2.5 and overheads to Brighton of about just under 2. So the total is still 4.5, but the split is 2.5 to 2. And if we go back up and look at what we did in traditional, we split it 3.6 to 900. So completely different split compared to what we're coming to now. So that's the danger of using one cost driver that's too crude. It misses how the products are actually consuming overheads. So once you have the total overheads, we can then allocate it per unit. So remember, in ABC, you will always do totals first, total basis, and then go back to per unit. So Essex is 2.5 over 32,000 units, and Brighton is around 2 million, but that is only 4,000 units because it's a lot smaller volume new product. So drastically different in terms of the size, the allocation of overheads, and then we tot them up to 15 and 736. So the key thing about ABC is you start on a total basis, allocate the total overhead, and then work back to per unit. You can't just cut straight to per unit. It doesn't work in terms of how you have to go about the approach. So that answers part B, where we have calculate the cost per unit for ABC. The next question then, and we're getting more into interpretation now, where we're looking to see the students actually understand what it means and possibly think about the implications as well. So why are the costs different? So let's bring down our ABC to cost figures. So it might be always useful if you're asked something like this, do a neat table so it makes clear to you as well. So there are the ABC costs. And we'll do, this is Essex. Tidy up this. And this is Brighton. And then we'll do traditional. So very similar to what we've done in OLATA before. But we're trying to make it neat that we can make good comparisons very directly because we have a nice neat table. So here, if you look at the difference, so the difference here is 35, roughly. And the difference here is 273. So the key point is, we're looking here at the differences. So I just left them in positive figures. Essex was overcosted by €34, or if you want to put that in percentage terms, because it's useful to think about in percentages, it was overcosted by about 14%. Whereas Brighton was undercosted by about 59%. So that's very important to understand, that using the traditional one, where we just use direct labour costs, completely distorted what a more accurate picture of the cost of the products are. So the key question is asking, why did that happen? Well, up above, we think about it before, we assumed that Essex assumed or used 80% of all overheads, right? And used all the activities associated with those overheads, and Brighton used 20%. Whereas actually, when we go to the question and we actually look at the activity analysis, well, it turns out it's not an 80-20 split across the board. Here, they actually use more than 50%. Right? So Brighton actually use a lot more than half of machine hours. They use 50% of the number of requisitions. Right? They use here a third of all setups. And here they use 125. Sorry, the wrong one. Get the calculator. They use 125 over 450. They use 27% of all movements. So they're the kind of things we're trying to think about, that we've assumed at the high level they use 20%, but actually when you dig down to all their activities, they use a lot more across the board. So when we come to activity-based costing, we capture that usage. And that's what I'm looking for students to say, that we're a lot more accurate in terms of whatever activities a product consumes, ABC will pick that up a lot more accurately, and it will reflect that in the product cost. So because Brighton is so activity intensive, it uses so many machine hours, requisitions and movements, it gets allocated a lot more of the cost. So even though it's only 4,000 units, it nearly gets allocated the total same amount of overheads, where Essex is 8 times the level of volume. So that's a key insight of why the two are different, because the different level of usage of overheads. Right? So that's a key thing to be able to interpret as well when you're going through the numbers. And finally then, suggest any additional factors which may have contributed to the decline in the company's profitability since Brighton cabin was introduced. Now here, a lot of the time you're given flexibility for students to come up with their own commercial thinking. But what I want you to do is be able to apply to the facts of the case as much as possible. So think about what's happened here. Brighton is a new log cabin for the European market. And what you're told then is sales are better than predicted, but profits did not increase. And you're asked, well, what other reasons might have happened here? So any additional factors. So there's plenty of reasons that are valid, and I give plenty of credit if you give a valid and justified reason. So some of the issues that you might identify will be, well, actually, there may have been, to some extent, cannibalization of sales. Whereas, yeah, you might have sold a lot more of the Brighton one, but maybe you didn't sell as much as the Essex cabin then, because some of the Brighton cab sales took away from other products. So one valid reason. The other one could be, we've only really looked at manufacturing overheads here. We haven't looked at sales and marketing. So particularly if you're going to the European market, and it's a new market, a new cabin, you may have used a lot more marketing expenditure, because again, it may be an indicator why sales were so good than expected. So your costs may have been a lot higher than expected, hence your profits were down. Or costs in general across the board may have been higher than budgeted. So we don't know what your budgeted costs were, we only have the actual. So it could be a case that that could explain why profits were down, because your costs were higher. So again, a lot of them, we're using the facts that we have, and we're trying to make it as applicable as possible to the facts of the case. So watch out for those two types of parts going forward. As we build to bigger questions, more detail, I'll be looking for you to explain why there's differences in numbers, and more importantly, the implications. And secondly, I might be asking you to interpret and explain particular reasons, strategic issues, as part of the background of the question as well. So we'll build on that in terms of Doyle Dairies and onto your questions in the coming weeks as well that I'll put up on loop. So this question was looking at traditional product costing and also activity-based costing.